So, you get to meet E today. We've been wanting to tell you about E forever. E is pi's bestie. And tell me what you know about pi.
It's tasty.
It is tasty. The mathematical pi, though, not so tasty. What do you know about pi? You met pi like back in grade 7. Tell me anything you know about pi.
It's hard to draw.
I don't know we can really draw a number.
No, I mean,
Like the actual character? What alphabet does it come from? Greek, and it's R equivalent to? What letter in our alphabet would be the same? Pi starts with P. Capital P or little p? It's little p. It's our equivalent of little p. What kind of number family is it in? The irrational, so it's that special little family off to the side. And what's special about irrationals? Keeps going forever and ever. There's no pattern. And actually, we're now starting to think, does it go forever? There are mathematicians that's their job, is to find out more and more digits of pi. I think they're up to, and don't quote me, I think 5 billion is the amount of digits they have now. Oh, it's all done by computers now. Computers revolutionized what we knew about math because now they can generate more and more stuff. But the irrationals are fascinating to mathematicians because we can't explain them. And anything we can't explain really fascinates us. So what is their purpose? Why are there these numbers? Maybe it's the secrets to the universe and we don't know it yet. Really, when you think about all the things we don't know yet, that's kind of freaky, actually. So E is pi's bestie. E is the second kind of most famous irrational number. You might have seen it on your calculator, but not really had a clue what it did. It's called Euler's constant. And there's a joke that says you're a real mathematician when you know how to pronounce his name, because it's Euler, not Euler. So unreal mathematicians will say Euler. You're like, no way, his name's Euler. He's a Swiss mathematician, so it's him that actually didn't invent this number, but he discovered it and he named it after himself. He chose the E because his name starts with an E, which is funny because it's not pronounced with an E. But maybe it is in Swiss, I don't know. It's always a small e, and it actually is usually italicized, which I know is for you hard to write, but it needs to be like a curvy little e. Can't be like with straight lines, it's a curvy e. It's approximately equal to the irrational number 2.718. Is it wahua? Is it random? Yeah, it's just like pi. Okay, so who can find the E button? That's actually the alpha character E. It's not the variable or the irrational number E. There's another button for E. Under log, but above ln. So it's a second function. So second function, the ln button. And what this allows you to do is put any exponent. If we want just the plain base value of E, we're going to put an exponent of 1. And there's our 2.718281828. And you're like, ooh, that looks like a pattern. No, it's not. It's completely irrational and random.
So that is the same as the E that's this.
Oh, does the alpha character do the same?
On my calculator, it's actually equal to pi.
Yeah, we have that too, but if you put it, will it actually give you the value? Oh, it does. Look at that. I had no idea. Awesome. So just some things about E you don't need to know, but it's really so very cool that I can't not tell you. There's a formula that's called Euler's formula.
That's pretty.
Yeah, he really liked himself. He liked to name after himself. And it says E to the exponent I pi. And I you haven't met yet. You'll meet him when you go to university. But I is another, it's not irrational, but it's actually called an imaginary number. There's a whole number family that doesn't exist. It's really freaky. This comes up a lot in engineering, any kind of natural sciences, you get I a lot. And what I is equal to is the square root of -1. And what looks wrong with that is it doesn't exist, and that's why it's called the imaginary numbers. It's so freaky cool. So if you take an irrational base and raise it to the product of an imaginary number and an irrational number, so you got a whole bunch of craziness going here on the left, it's equal to 1. Mathematicians think that's beautiful. Like, how does that happen? Crazy, freaky numbers, put them together, 1. Euler's formula. E is actually equal to 1 plus 1 over 1 plus 1 over 1 times 2 plus 1 over times 1 times 2 times 3 plus 1 over 1 times 2 times 3 times 4 plus dot, dot, dot. So although we say it's never ending and it has all these decimals, really it's a non-decimal value because that doesn't have decimals in it. When you put all that into your calc and you keep getting bigger and bigger and bigger numbers, it all comes down to approximately 2.718. Again, this fascinates mathematicians because why? Where does this come from? There's a second formula that will come up in physics, and I don't know if it will in high school physics, but if you go on and take physics, and if you say, it says if you take E and raise it to the I theta, so again, that imaginary number that doesn't even exist, and you times it by some random angle, you get cos theta plus I times sine theta. I know. And if I were to square these, you actually end up getting basically the unit circle. So somehow this E value is tied to the unit circle. It is just so freaky cool. But you don't need to know any of that. It's just really exciting. Why do we need to talk about E? Well, in nature specifically, a lot of biology, you'll get it in finance and economics, you'll get it in physics, we often get a log with a base E. So the default base is 10, but sometimes you need a base of the irrational number E. Think about that, the base of 2.711828 dot, 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 dot. So because that sometimes got a little bit confusing with is the default 10, some people wrote the default as E, and it was all confusing in the math world, we decided to come up with a new notation. And so instead of writing log base EX, we write it as lnx. And what that means, it's called the natural log of x. And most people were like, but wait a second, natural log, wouldn't that be NL? Well, what country or what mathematician of what origin came up with lnx? So what language do they tend to do things backwards? French. It was a French mathematician, and in French, it's log naturel, which is ln. So it's all because the French do things backwards. So you have an ln button on your calculator, which, if you know my first name, it is my favorite button on the calculator, because none of you have your own button, but I do. And all it means, it's a log with that special base of E. So the log button is base 10, the ln button is a log base E. Today we're just going to practice graphing and solving equations, and tomorrow I'll show you the applications. Is why do we need logs? Why do we need this E? Why do we do this? So y to the equals e to the x, and y equals ln x are inverses of each other. So graphically, let's see what they look like. So we're going to start by graphing just e to the x, and then we'll take the inverse to get ln x. Don't cheat and look at it on your calculator. Because how do we graph any exponential? Whether it's a 2, a 3, any kind of base, how do we graph it? We just plug in values. So let's put in 0. What's e to the 0? Well, what's anything to the 0? Is 1. Let's put in e to the 1. Approximately 2.7 because we're graphing. So we get 1 and 2.7. E to the 2, so grab your calcs. How can I find out e to the 2? How do I type that in? What's going on here? Second function, ln, whoops, second function, ln, and then a 2. 7.4 if we go to one decimal place. Okay, so 2, 7.4. Again, I'm not really going to care about the left-hand side and the negatives because I know it's coming down towards the asymptote. Swoops through those points and up. So it looks like a normal exponential graph, which it should because e is just a number. It just happens to be a funky, really weird, freaky number. Okay, so that is e to the x. Let's write in that asymptote because we know it's still there because it's exponential. So to go from e to the x to the ln x graph, all we're going to do is just inverse those points. So 0, 1 is going to become 1, 0. 1 and 2.7 is going to become 2.7 and 1. 2 and 7.4 is going to become 10. And we know it comes from the negative y-axis, swoops through those points. And we know the asymptote switches. So it looks like a normal log graph, and it should. It's a normal log. It just has that funky base of e. Still with me? Okay, so these are normal exponential, normal log functions. They just have this number e in it. So I'm just going to do a little theory off to the side. You don't need to know this, but I always like to show you the why things are what they are. I'm going to take the equation ln e and make it equal to x. And what I want to know in a second is what is x equal to. Okay, so even though it has ln, this is just a log equation. It's just a log with a base e, but we don't write that because it gets confusing, so we write ln. So what are the steps to solve a log equation? Logs to one side, numbers to the other. Smush down into one log, done. Third step. Change to exponential. Now we don't see, but we know there's a little base e because that's a definition of an ln. So e is going to come over, bump the x up. ln disappears and e stays. What's the exponent on the e on the left-hand side? We don't see it, but we know it's there. 1. Well, this turns into a common base question. So as long as I have the common base on both sides, what do I get to do? Drop them, so I get 1 equals x. So the useful fact we're going to use over and over and over is ln e equals 1. Again, to mathematicians, so freaky. You take log, you put it to an irrational base, then you take the log of an irrational number, and it all comes down to 1. Freaks us out. Okay, there's all the theory behind e and everything else. These are the types of equations we're going to solve. So they're just exponential or log equations. They just happen to have an e stuck in them. And why? Because there's tons of applications, especially in the nature and natural sciences, that end up using e. Oh, let me guess. Now, interrupt us again. She couldn't just say the same people I called 20 minutes ago. No. So have your little foldable in front of you because we're going to do some exponential, some log, and you're going to tell me which it is, and you're going to tell me the steps. And again, until you start to really practice these, sometimes the steps get confusing. So first question you ask yourself, is this an exponential function or is it a log function? So am I opening the door on the right or am I opening the door on the left? How do you recognize an exponential equation? Variable in the exponent. How do you recognize a log equation? Because it has a log or an ln, which is just a log in it. So exponential or logarithmic? Exponential. So open your exponential door. Step 1 for an exponential equation. Take log of each side. The only thing that's different in this one is because there's an e, we're not going to take normal logs, we're going to take natural logs. So natural log on the left, natural log on the right. It's the only thing that's different. If there's an e, we use ln's. And again, ln's are logs, they just have a special base of e. Okay, step 2. That's step 3. We can't move till we've done what? Yeah, we have to expand using our log laws before we can start to move. Okay, so exponents become coefficients. Oh no, oh no. Take a look at this. What did I just tell you n and e is equal to? So these are actually easier than log equations because the minute you have that ln e, it's 1. That's why we choose to use an ln as opposed to a regular log. If I had log e with a base of 10, I can't simplify that down into anything. There's this handy little fact that ln e equals 1, so we tend to use it quite a lot. Well, that made it easier. How do we get rid of the 1? How do we get rid of the 1? Could I make this ln 6? No, no, it's just ln 5 plus 1. How do I get rid of the 2? What's the last step for an exponential equation? Grab your calc. Yep. So does the question have an ln or does it have an e to the something? So it's exactly what you see. Open the bracket, ln 5, close the bracket, plus 1, close, divide by 2. Three decimal places unless the question says otherwise. Sorry, 1.305 is the offer. Confirmation. Bless you. That's a natural log equation. The only thing different is it started with an e, and because of that, we put an ln instead of a log. So you have to open the whole top, and you have to close after any kind of log. So you're going to have to open the whole top, and you're going to close there. It's irrelevant because it's only a 2, so it won't matter either way. We usually like e equations better than normal ones because it's way less work. 3 to the x minus 1 equals e to the 2x. So exponential or logarithmic? Exponential, step number 1. Logs on each side. Because there's an e, we're going to ln it. Now just be careful, we can't turn this ln e into 1 yet because it's got an exponent, and the exponent comes first. So you have to use your log laws. Log laws said that the exponents drop down in front as coefficients. So I get x minus 1 times ln 3 equals 2x ln e. This is where I can turn it into 1 because I'm multiplying. Big question with logs and brackets is, can we distribute or can we not? So it is a no touchy or it's a yes, multiply. How do you know? Because it's in front, so we're going to multiply this guy through. So x times ln 3, x ln 3, so don't get too fancy, just smush them together, minus ln 3 equals, don't want to divide yet. X is to one side, non-x is to the other, so I'm going to keep x ln 3. What's going to come join it? Negative 2x. And the other side, ln 3. Isolate x. What's the only way to isolate x when it's in 2 terms? Common factor. Thank you. How do we get x by itself? Cancel? Ooh, why not? 'Cause? A little more specific. Because we never do, yes, because you can't cancel half of a... Can't kill a puppy, don't tell that to your university professor. Because you can't cancel half a binomial. Okay, so again, just like log equations, you're never canceling at this point. Offer. I say offer and then you give me an answer. It's the way this game works. Negative 1.9 rounded to 3. That sounds confirmed. So we're bracketing, we're closing, we're closing, we're bracketing.
For that you think that you if it's there, does it just disappear?
Well, we know it's equal to 1, and what's 2x times 1? So it disappears, but it's just because we multiplied it.
Okay. So you don't have to put times 1?
You can if that makes sense to you. If you don't need that step, don't put it. How are we feeling so far? ln x plus 1 equals 2 plus ln x. I have my own function, just saying you don't. Exponential or log? Okay, so close the right-hand side, open the left-hand side. Walk me through it. Logs to one side, numbers to the other. So I'm keeping my ln x plus 1 equals. Simplify using log laws, so coefficients become exponents, adding becomes multiplying, subtracting becomes division, smush it all down into 1 ln. Cancel the x's? No, and if you did that, you'd have no variable, which probably tells you you've done something wrong. Okay, step 3. Okay, what's the base that we don't see? E, right, because ln always has a base of e. So e is going to go over, bump this up. X plus 1 over x stays. Yep, so times by e to get rid of it on the bottom. But then we have x's on each side. So when we have x's all hanging around, what do we want to do with them? Bring them all together. So x is on one side, numbers on the other. So x minus, this is just a number. E squared is just a number. This is like 5x or 17x or negative 2x. It's just a number. So if we pick this up and bring it over, e squared x, and we need to kick the 1 out, negative 1. Okay, so e squared is just a number. Don't let it scare you. It's just a number. In fact, it's whatever we said it was before, 7.4. Isolate x, so when it's in two terms, well, it's the only way to isolate it. Bless you. Is the last step of a log equation use your calculator? No, never. These are always non-calculator questions. What do we do? We leave it. This is just like in the unit circle where we left stuff with pi, we leave stuff with e. So we like exact values where we can, so we're done. This is not a calculator question. Okay, so you might want to make a note, leave with e, because you might panic when you get to the exam and you don't have your calculator for this kind of question. E's make us happy just like pi's make us happy. They're very pretty numbers. You missed e! It's very exciting.
That's fun. That took me a while. I thought you were just being festive and being all Christmassy with it.
No, it's all about e. It's January 22nd. It is the exam. You've already been here 2 hours. You're tired. You have to pee. You're cranky. You turn the page. This is the question. What's the very first thing you need to ask yourself? What kind of equation? Because that's going to put the steps into your head. Is it exponential or is it logarithmic? How do you recognize an exponential equation? Variable in the exponent. How do you recognize a logarithmic equation? There's a log. So is this exponential or is it log? It's both. This is an exponential logarithmic equation. You might want to jot that down. It's both. So exciting. Why is it exponential? T is in the exponent. Why is it logarithmic? It's got an ln. Okay, this is so exciting. So what do we do first? We don't have steps for a combo question. Well, don't forget, point of an equation is always to solve it. So you need to get that variable all by itself. So you need to get it out of the exponent. What's the only way to get a variable out of an exponent and down into the main equation? You have to put logs on each side. Are we putting logs or are we putting ln's and why? Why are we putting ln's? Because there's an e. So step number 1, we're going to ln it. And don't forget the other side. That's a really common mistake when there's just a number because you're used to equations equaling a number. But if you log one side, you have to log the other side. Okay, we still need to get that guy out of the exponent. So what's our log law that says? Coefficient. So all of this is going to drop in front. What do you mean I just had that? What? Handy little fact, equal to. Okay, now what does your brain tell you to do? Except for bail and run away. Probably you want all the ln's together. Okay, so let's move them all into one side. Okay, now you got a bunch of ln's hanging around, so the natural step would be to simplify them. Let's combine them all together down to one ln. Why are we dividing? Because it's a subtraction. Okay? Again, we're just solving an equation, so we're picking away at stuff until we have the variable by itself. So we're down to the point now we need to get rid of the ln. What's the only way to make a log or an ln disappear? Exponential. What's the base that we don't see? So he's got to go over. He's got to bump that 0 up. I heard somebody say, so it's 1. Multiply by. Think about that. We took this crazy number e, raised it to a natural log with a bunch of crap, and all of that turns out to equal 3. Freaks us out. Is that enough? Do you want to just take the sheet? Try number 5. Walk me through. I just gave you that and said simplify it. How? Oh, we can factor what now? Okay, what would you, okay. She who said she's stuck is not stuck. Why can we cancel here and we couldn't cancel before?
That was fun.
Mm-hmm. Number 6. Exponential or logarithmic? Both. Find a friend, give you a couple minutes. Okay, walk me through it. Offer to ln both sides. Okay, simplify how? And we're like, it's not quadratic, thank God. Who got it? You like logs? I like logs too. Yeah. Worksheets in the back of your package. It says natural logs. Why was the lumberjack a good dancer? Why was the lumberjack a good dancer? He had natural logarithm. Come on.
Ha ha.
It's starting you off slow, so the first part is just calculator, just practicing doing the values on the calculator. Yes, and then there's a couple of sketches, and then some expanding, and then the actual solvings at the very, very bottom. It's a little bit of everything. I know. They're hard to find at this level, though. They kind of think, high school, you don't need them anymore. I know, when I find one, I get pretty excited. Yes. Do you still need this stuff? You okay? Bring me back that question where you asked me, because I think you miscopied it. Because I think it was the same as this one. Oh, I hear it all the time.
The shoe joke wasn't the best.
Which one?
The shoe joke, right leg for the baby.
That's so funny. Oh, love it.